This video will be covering two requirements of the Programming Merit Badge for Scouts BSA. We will be covering number 2 and number 3 here. We'll be talking through the history of programming languages and computers in general, and then also general knowledge of different programming languages that are out there, and then a few devices around us every day that you may not realize actually have programming in them. So we'll get started with history. Let's go to the fundamentals of what a programming language is. I really like the Simple English Wikipedia version. It keeps it nice and simple, which is how we all understand things. It's as it defines it here, I like this. It's a type of language that tells computers what to do to work. So you remember C-3PO from Star Wars, right? He was a protocol droid, and his job was to be able to translate between all these different languages. There's a lot of different languages with computers, but they all boil down to the same thing of trying to get a computer to run a set of instructions. So like it says here, a programming language is a set of instructions that tells the computer to do something. A very nice analogy for this is baking or cooking and recipes. You have a recipe, and that's like the source code of a program. So you have a list of ingredients, things that you have to get out and get all ready. Once you have that list of ingredients, then you're going to follow a set of procedures to put that list of ingredients together in the right way. If you do it right and you go through the entire process, you end up with something hopefully very yummy that you and others can enjoy. A computer program is similar to that. You have a list of ingredients, of things that you know you can use, and you have to put them together in the right way. And in the end, it hopefully does something very useful. A lot of the software that you see these days is made of, big, very large sets of software. But even if you break those down, they come down to very simple pieces of software. For example, whenever I type the letter A on my keyboard, I want the letter A to show up on the screen. There's a lot of paths that the computer takes to get to do that, but it's a simple operation, right? And if we look deep down, it's all just a computer following a set of instructions to do something. So let's head to the history of computers. Some of you may have been familiar with this in school, so hopefully it's not too redundant, but let's head up here and we're going to go at a high level. Again, this is on Simple English Wikipedia. And so it defines it as a computer is a machine that you give it data, input, and then it processes it, and then outputs it. That's what a computer boils down to. There's all types of computers, all the way from the very simple to the very complex, which we'll hit in a second. But let's start with the history here. So I like this here. It says that as it starts the history, why did we think that we needed computers in the very first place when humans said we should do something different in order to help us out? Why would we do that? And that's because trying to do very complex math in your head is very hard. So 584 times 3,220, it would take me a while to work that out, but even my head, I can't do that. If I worked it out by hand, sure, I could do it, but it'd be pretty slow, right? Computers are very good at doing very simple things over and over, and you can build those simple things into very complex things. So let's look at a few examples. Right here is a loom, and a loom is used to, make tapestries and rugs, and I'm sure all kinds of other things I don't understand, but it's full of a bunch of tiny components that if you take those components and you put them in the right order at the right time, then you end up with a very nice tapestry. It's something that can be programmed, like it says here. Another very good example, a simple one, is an abacus. So you can see here it's got the red and the white dots, and it's just on like a little pole that you can slide back and forth. This was used to be able to count without having to keep track of everything on paper. So this is one of the first calculators is what this is. So that was the very, very beginning. Okay, so let's move on down. we got into the 1600s, 1800s, and then right around in the first half of the 20th century. So 1900 to 1950 is really when computers started to take off. At first, it was the military that had a pretty big interest in it, and it was to help with the war effort in World War II was one of the main reasons it became popular. One of the famous ones is called the ENIAC, and I have no idea what that stands for. Let's find out. Um, Electronic Numerical Integrator and Computer. So, fancy word for a piece of it's a whole bunch of vacuum tubes. You see these little lights in them that it was able to do math pretty quickly, not as quickly, not near as fast as the current computers that we have, but it was much faster than humans. So the ENIAC was one of the very first, what we would probably think of as a computer with mechanical and electrical components. So you can see that was 1945. We, as humans, continued to improve and improve and improve and improve these machines. By the 1950s and 60s, they were getting smaller and smaller. And so something like this here this is called a microprocessor. And you can imagine that, like the loom that we saw at the beginning, that they had many hundreds of years ago, is still kind of like this. It's a bunch of small uh, ways that you can move electrons and data around in order to make it do something. It's basically doing math very, very, very quickly, millions, if not billions of times per second, in order to make something happen that's useful to humans. So that kind of gets us to where we are today, to where you see these microprocessors right here. If you open up a computer, this is the type of stuff you see. You see green, and it looks like a maze, right? And that's because that's a different path for all those pieces of data to take to eventually get something useful for humans to see or use. The different types of computers is a nice list here. The first one that people think of is it's a personal computer, and this is one that's probably almost 20, 30 years old at this point. You can see that the monitor's pretty large, no flat screen monitors back then. The keyboard is pretty big and bulky, along with the computer tower here. A lot of these have turned into, these days, they're laptops, but it's still the basic components, right? You've got a screen, you've got a keyboard, and then inside the laptop are all the other components that make the computer work. So that's what we usually think of. There are several other types of computers that are still very popular these days. One of the next ones that you probably hear about, perhaps on the news or with internet companies, is a server. A server it's a computer that serves different types of information to different machines. Servers are kind of like it's a protocol droid that all it does is talk to other computers. It usually doesn't interact too much directly with humans to where we have a mouse and a keyboard. It does have those, but more commonly they're used to be able to give computers information. So for example, when you log on to google.com, your computer is contacting other computers that are out there, and one of them is actually giving you the web page that comes back for google.com. So humans will program these in order to be able to do things that they can't focus on all the time. Computers are just sit there and they're on, and they give information to other computers. And one of the last other ones I want to go through for different main types of computers is called an embedded system. And this is mainly what I work on. An embedded system is a fancy way of saying it's a computer, usually without a monitor. So an embedded system still has this same green type of circuit board, and it's got all these different components, and it's still a maze of things that happen, but it's usually not with a monitor. This is important because hardware and programming can still be very useful even without a monitor sometimes. For example, on your thermostat has one of these embedded systems in it. So on your thermostat, you go change the temperature. It's too hot or it's too cold in the house. you punch a little thing to make the temperature goes up. The computer realizes that you put increased numbers or decreased numbers, and then it turns on the heater or the air conditioner appropriately. There's wires that run from that thermostat to the heater or the air conditioner, which makes it turn on. So that's an embedded computer, and I'm sure that you all have also seen tablet computers. A tablet is very similar to the personal computer that we saw up here, but the big difference is that there's no extra keyboard or no extra monitor. And that's because the monitor itself is the keyboard, and then also it's the way that you see things, and also behind that monitor is all the other stuff that goes into making the computer run. So a tablet is about as small as we've gotten these days for a personal computer. So that's the history of computers. I would say that the three big milestones that humans have hit as part of that requirement are whenever we first started trying to make mechanical machines, no electricity back then. That was the big first milestone of having something that was a programmable device. And then I would say the second big milestone was something like the ENIAC, to where it was a computer of vacuum tubes and data that could go faster than humans, but it still took a lot of time to program. And I think the third major milestone is about where we are today with a tablet computer, to where we've shrunk all that down into something very small and very useful, like my phone here. And I think that's a nice third milestone, and that's about where we are today. So that's requirement 2 here. Let's talk, well, that was requirement 2A. With 2B, we can discuss the history of computer languages as well. We kind of hit the history of programming right there. So the list of programming languages and the evolution of it boils down to it's a progression of languages that people have used throughout the years. And you can think of a language as a way to write a set of instructions for a computer. A very, at its highest level, whenever you say, if you have an Alexa in your house or something, and you say, Alexa, play me a song, then you are communicating via a protocol of your voice. Oh, see, there she is. You're Alexa, pause. You are communicating with her, and she understands that. That's a protocol. On the other far end, if you had something like the abacus, you have to move each little piece of data and it stays there. Then you have to interpret that. That's the simplest form of a computer. Languages are everything in between that. So the languages that I work with at work, will say, I have some data from a medical device and I want you to draw it on the screen. And whenever you draw it on the screen, I want you to highlight certain areas that the doctor might be concerned about. So the goal of that computer is to be able to help doctors, and the way it gets its data is by using some electronics that are looking at a patient. So there's many different types of programming languages. A very nice way to, I think, get a high-level view of it is, again, the simple Wikipedia. And there's a lot of programming languages that are out there, but we're going to go through just a few of the very common ones here. Let's go through something that is very popular these days. Probably heard of Python. Okay, so Python, it was made around 1991, and it was actually made as part of a joke of a television show. There was a Monty Python's Flying Circus. So, the language itself isn't the joke, but it was named after it, and they were trying to have a sense of humor. So let's just jump right in and look at something like Python. Okay. So you can see down here, this is a set of instructions for a Python program. And let's just go through it line by line. This try is a way of saying to the computer, I want you to do whatever comes after this try, and if something doesn't go right, I want you to go to an except. So an exception. So something bad happened, but otherwise, just keep going past the except. So what it's going to try here is to say age, which is, you can think of it as it's a temporary piece of data that we're going to pass around, and we're going to give it the name age because we don't know the number that needs to go in it yet. So we're going to assign age equal to an integer, and that's the int is short for that. And an integer is just a number, right? And then with the way that we get that integer is inside these parentheses, we say input, which is the name of a function that asks the user for input via the keyboard. And whenever it asks the user, it's going to say, how old are you? Question mark. And then it will ask us, we'll give it a number, we type it in, we hit enter, it gets assigned to age. It got a good number, and then so it keeps going past the exception because it's not an exception, things went fine. You didn't give it like you didn't say the word guitar instead of an age, instead of a number, so it goes to the else. And so the else says, if the number that the user put in is less than 0, then that doesn't make any sense, right? And if that happens, you're going to say print, you can't be less than 0, that's silly, and then move on. If the age is not less than 0, then it doesn't print this, and it goes to the next thing that says, well, else, if the age is greater than 100, then it prints, that's really old, and then you're done. And then the last option is that if you are not less than 0 and you are not greater than 100, then that must be this last case, which says I'm going to print you are, and then there's this %s years old. The %s says I want you, computer, to print something right here where the %s is, but I'm going to tell you what variable to use. So we're going to print %s, and then we're going to print age, and the age is from up here is where we got from the user. So let's give this a whirl here. So we're going to hit run. So for how old are you? I'm going to say I am -8 years old, and it's going to say that doesn't make any sense, right? So I'm going to go back. Oopsies, hope I didn't lose my program. Oh darn, I lost my program. That's too bad. I can get it back here. Okay. Okay, so you could see it printed less than 0. It said that doesn't make sense. If I were to input 102, it would say that's old, and otherwise it would say I am, if I put in 36, which is what I am, it would say you are 36 years old. So that is one type of programming language. This is about as fancy as programming languages have gotten these days. I do a lot of work with Python where I work, but there are also a lot of other types. So the next type to learn about is something called HTML. HTML is a fancy word for how to show a web page. It stands for Hypertext Markup Language. And so let's go ahead and look that up so you can use it for reference. Okay, so it says Hypertext Markup Language is language for creating a web page. Web pages are usually viewed in a web browser. So where we are right now, it has pictures, it has links, sometimes they have videos, like on YouTube, and underneath how the computer displays this is code. And I brought this up a little bit earlier as an example of the HTML that is underneath the page that we were just on. So you can see that it has these little brackety things for HTML. So this says this is the beginning of an HTML page. And then the head says, here's a section of this page where I'm going to define a few things like the title of the page. I'm going to define a link to somewhere else where they could click on. And then it gets more and more into the, there's some complex code in here, but it all boils down to, I want to show the user a web page that looks like this that they can do something with. So that's another example of a programming language. HTML is actually being used to display Python here that we just did some testing with. So that's the evolution of programming languages. For general knowledge of even more different ones than the ones that we just talked about, I would like you to go through the simple Wikipedia version of programming languages. And that's at this site right here. And let's see if we can find a list of programming languages. Here we are. So I would like you to go through and pick out 10 of these, and then write down and be ready to discuss for each one of them what its primary purpose is, for where it's used, and why it's preferred for that. So this isn't too bad, because if you go to each one of these, then it gives you a short history about why it's used, what it is, and what types of computers it's used for. Let's go to Python, since we first looked at it. In Python, we learned about it. It was made in 1991, and you can see that it's a good programming language for beginners, and it's also very useful for making programs that you need to be quick. So it doesn't take as much time as some other languages. So it's used in a lot of different ways, that for each one of these, you can look and see if you can get an idea about how you would use it. As another example, we'll do PHP, which stands for Pre-Hypertext Processor, and then it's mainly used for websites. So you can see PHP is code run on a web server. So for each one of the 10 that you choose, and any 10 are fine, then go to the page, write down what industry, if you can find anything that it's used for, and why. Okay, so that's assignment A, and so I'll leave that to you for us to discuss later. And then the second one is also an assignment for you, but I'll give you some hints here for 3 different program devices that you rely on every day. So I'd like you to think of, video back on here. I'd like you to think of things in your house that you think have those little green boards in them. That's a programmed device. So put together a list of a few. Look for things around your TV. Look for, we talked about a thermostat. That's one. That's a freebie. And but also, I want you to think about it. Do cars maybe have some? Is it possible that all the things that you're using, like AirPods, are AirPods a little computer? The answer is yes. That's another freebie. Well, I'm about to give you guys all 3 answers. So put together a list of your own of things that you think are programmed devices, and then we will discuss them. So that is requirement number 2 and number 3 of Programming Merit Badge for Scouts BSA.